Alright, this is part 3 of our lesson about inscribed angles and circumcenter. In this video, we're going to continue our work with inscribed angles and inscribed polygons, but we will also finally get into a discussion about the circumcenter and perpendicular bisectors. Okay, number 19. Alright, we have learned that if you have a quadrilateral that is inscribed in a circle, meaning the vertices are on the circle, the opposite angles are supplementary. That means the opposite angles should add up to 180 degrees. So 3x plus 63 should equal 180. They are supplementary. So we simply subtract 63 from both sides, and I get 3x equals 117. Then I need to divide both sides by 3, and I get x equals 39. Alright, so that's one of the variables. Now let's do something similar for the y value. So, the 65 and the 4y minus 1. These two quantities, they are not equal. I'm not going to set them equal to each other. They are supplementary. That means they add up to 180. So that means that 4y minus 1 plus 65 should equal 180. Now, these parentheses are just there to help you see that I'm talking about 4y minus 1, but they're not really doing anything other than grouping. So let's combine these like terms. Negative 1 and 65 together make 64. So I have 4y plus 64 is equal to 180. Alright, I would then subtract 64 from both sides. That will give me 4y is equal to 116. And then it's time to divide both sides by 4. And that's going to give me y equals 29. Alright, so those are the two answers to number 19. Alright, let's do something similar with problem number 20. Alright, let's stop and notice that we have every arc on this circle except for AB. So we know that a circle makes a total of 360 degrees. So if I take that 360 and I subtract the three arcs that I'm given, so minus 84, minus 80, and minus 152. That should leave the one missing arc of AB. Okay, so it'll be like this, and kabam, 44. So the other angle, the other arc is 44 degrees. Now, with that in mind, okay, we should now be able to find the measure of angle C, because look at this. Let's see. If we look at this arc right here, I'm talking about arc DAB. That is the arc that goes with this angle, this inscribed angle. And remember how the angle is half of the arc? Well, let's figure out how big this arc is. It's 84 plus 44, right? So 84 plus 44, that's going to be 128. Alright, so if I take half of that, that should give me the size of angle C. So half of that is 64. Okay, so this is a 64-degree angle. Now, this angle is labeled as 4x. So what does that tell you? So that gives us a tiny little equation that 4x should equal this 64 degrees. So all I have to do is divide both sides by 4. So that's why x is going to be 16. Okay, let's see if we can do something similar for y. Okay, let's see. If you look at the angle where the y is, alright, angle D. Alright, look at this angle. Now, let's look at the intercepted arc. Alright, which goes from here to here. So this is the intercepted arc. Alright, now we know that this arc is twice as big as this angle. So let's see. This arc is 44 plus 152. That is 196 degrees. That's how big this blue arc is. Alright, it's just the 152 plus the 44. Now we know that this inscribed angle should be half of that. So if I take that and I divide by 2, I get 98. Okay, so this angle right here is 98 degrees. Okay, this is 98 degrees. But look what you see right there. 98 degrees is labeled as 7y. That means I have this little equation. 7y is 98 degrees. So of course I'm going to divide both sides by 7. So that's going to give me 14. Alright, and that's why y is 14. So these problems are just like little puzzles. If you look at them the right way, they can be quite fun. Now, let's look at number 21. Okay, let's do the same type of thing. Okay, let's start with angle G here. Alright, look at this angle, angle G. Alright, now look at the inscribed angle. I'm sorry, look at the intercepted arc. That's what I mean to say. Alright, that blue is my intercepted arc. That is 96 plus 48. That is 144 degrees. Okay? Now, half of that should be the inscribed angle. And that's going to be 72 degrees. Okay, so that's this angle right here that we just found to be 72 degrees. But you see how that is labeled as 12x? That means we have this little equation. 12x is equal to 72. Alright, this 3y is a different angle. Don't think the 3y is the angle G. 3y is angle H. That's coming up later. So this 12x is the 72. So of course we're going to divide both sides by 12. And that's going to give us x equals 6. So that's one of our variables. Now let's go back and find y. Okay, so if I'm talking about y, Now I'm talking about angle H, because that's where the 3y is. Alright, so let me just really highlight it. So here's angle H, like this. Okay, now look at the intercepted arc. Alright, it goes from here to here. Alright, look, there's something that we need to do first. We were given every arc of this circle except for arc FG. So I guess I should probably find that before I do anything else. So it looks like we're going to need arc FG. So focus your eyes on this orange arc. Now we have the 45, the 96, and the 48. We have everything except for FG. So if I want to find it, I keep in mind that the entire circle is 360 degrees. So if I start with 360 degrees and I start subtracting, if I subtract 45 and I subtract 96 and I subtract 48, that should leave FG. Looks like this. That's 171. Okay, so that means that FG here is 171 degrees. I'm going to need the space back actually. Okay, 171 degrees. That's FG. Now we have all of the arcs. So let's get back to finding the intercepted arc for angle H. And the intercepted arc is this one. Alright, now this blue arc is the 171 that we just found plus the 48. Alright, those are the two arcs that kind of split here. Those are the two arcs that make this blue arc. So 48 plus 171, that's 219. 219. Okay, now half of that should equal the inscribed angle. Now this is odd, so it's going to be a decimal. Okay, so half of 219 is 109.5. But now I've got this tiny little equation happening. The 3y is in the same position as this 109.5. These are equal to each other. They both represent the same angle. So I should make this little equation that 3y should equal 109.5. So I'm going to divide both sides by 3 to get y. So y should equal 36.5. Okay, so those are the two values for problem number 21. Alright, how about number 22? Multiple choice. What is the value of x in the figure shown? Alright, look, what I have here is an angle, an inscribed angle, and the intercepted arc. Okay, so look, this is the angle, and this is the arc. Now, what is the relationship between the angle and the arc, the inscribed angle and the arc? Well, there's two ways you can look at it. Alright, I'm going to put it in words off to the side over here. Let's see. One way you can look at it is you can say the arc is going to be double the angle. Or you could say the angle is equal to the arc divided by 2. You could use either one of these ideas. I try to excuse me, I try to avoid fractions when I can. So I'm going to use the one where we say, oh look, the arc should be double the angle. So let's fill in the expressions that we have for the arc and the angle. So the arc should be 2 times the angle. So that means the arc is 9x plus 21. So that tells me that 9x plus 21 should equal. Now, 2 times the angle. Well, the angle is 5x. So that's 2 times 5x. So I've got the arc is 2 times the angle. 9x plus 21 is 2 times 5x. So it's just a matter of solving this little equation. So 9x plus 21 is equal to 10x. Alright, I would subtract 9x from both sides if I were you. That's going to leave me with 21 is equal to x. And that is actually what we're trying to find. So that's why D is the answer. Alright, fascinating. Okay, in the next section of the lesson is where we finally get into perpendicular bisectors and this thing called circumcenter. But it's once again taking a long time to get here, so I am going to stop this video here, and I guess we'll have to make a 4th part for the rest of the homework. This is shaping up to be a really long assignment. Alright, I will see you on the next video. We'll learn about circumcenter and stuff.